Hello, hello. I welcome you once again to another edition of our discussion in mathematics. Today's lesson is going to be a continuation of the topic we started, which is set. What did we say set is? I hope you could go back and quickly review the previous lesson or go over the few things that we discussed previously before you continue playing the video. That is if you cannot remember. Okay, so let's first take a review of the previous lesson that we had on set and some components of it. We looked at the various types of sets. We looked at operations on sets and certain key components that are very vital to the understanding of our lesson. We said that when you have a bigger set from which smaller ones are formed or obtained, then the bigger set becomes what we call the universal set. And to represent that on a Venn diagram, we use a rectangle. And the bigger one is represented with the letter U. You can equally use a different letter. The smaller ones, which are the subsets, are represented with circles within the rectangle, the universal set. Now, imagine A and B are the subsets of that universal set. Then when we combine the element of A and B, that gives us what we call the union of AB. So A union B. And the illustration here, painted green, represent that A union B. The other members, which are not part of the A union B, but are also still part of the universal set, who occupy this region, which is not shaded green. They can be represented anywhere here. Now, when we consider A and B again, they may have some common element or element in common. When that happens, we say A intersects B, and the intersection is what is represented in the second diagram or the second rectangle with a green portion here. So this portion represents the elements that are in both A and B. When we also consider the set A alone, we have what we call complement. The complement of a set, of a subset, are the members of the universal set which are not part of that subset. So if we take A, the other members of the universal set which are not in A become what we call A complement. And that is what is shaded. All the region around A, which is green, represent A complement, meaning they are part of the universal set but cannot be found in A. So similarly, we can relate what we just discussed to this diagram here, where we have A containing all the members in this loop or this circle. That represents A. Then the members of B are the element in this loop, and that of A will be 1, 2, 3, 5, 6, 9, whereas B will be 2, 3, 4, 5, 7, 8, and 10. So if we combine A and B, the complements are the members in the universal set that are not there, which will include the 11 and the 12 outside the circle. Similarly, if A and B do not have any member in common, then it means the two sets are said to be disjoint and the circles will not overlap. They'll be drawn separately in the rectangle. As you can see here, the members of A are the ones in the circle, the bigger circle A. The members of B are the one in this circle, the smaller one. And their complement are the ones within the rectangle, but not in any of the circle. Let's review the cardinality, the elements representation that we did last week. Last week, we said that if P is a universal set, then instead of writing U on the rectangle, then P will be on the rectangle. So if P happen to be the set of counting numbers less than 11, then we'll have the set P to contain these elements, 1 to 10. If Q and M happen to be subset of P, whereby Q is the factors of 10 and M is the multiples of 2 less than 12, then respectively, this will be their members. We can then make the following conclusion, that when we combine A, Q, and M, that will give us Q union M. And that will give us 1, 2, 4, 5, 6, 8, and 10. However, their intersection will contain only these two members, which is 2 and 10. Now, when we look at the union compared to the universal set, we can see that 3, 7, and 9 are part of the P, which is the universal set, but are not part of their union. Let's see how we represented them on the Venn diagram last week. The P will represent the rectangle, whereas M and Q will represent the two loops. This region, where the two circles overlap, will contain the elements 2 and 10, which are common to both P, Q, and M. Then, the remaining members of Q, which are not found in M, will occupy the region here. That would be 1 and 5. Then the remaining members of M, which are also not found in Q, will occupy the region here. As you can see, 4, 6, and 8 are found only in M, so they occupy the region behind the section where the two circles overlap. However, you will agree with me that 3, 7, and 9 become the complement of M in your Q because they are in the universal set but not part of the union of P and M. Again, we can also agree that if the universal set contains too many elements, let's say for instance, counting numbers up to 100, it may become difficult to illustrate that on the Venn diagram because the numbers involved will be many. So ideally, we rather use cardinality. But before then, let's still buttress our understanding of this representation. When we have the illustration on the Venn diagram, where we saw 1 and 5 being only in Q, we can represent that region using the Y. Only in X, we can represent that region by the X. Then the intersection with Z. Whereas the complement will be represented by the W. This implies that all the members found here, when we put them together, would then become the members of the bigger set, which is the universal set. This implies that X, Z, and Y plus W should give us all the elements that should go into the rectangle. And that's what we see here. However, X plus Z plus Y will represent the union of A and B. The union of A and B, whereas W become the complement of that union. Similarly, we can also still clarify it by saying this region is for only A, that region is for only B, whereas the yellow becomes the intersection. And the remaining region outside the loops is the complement. To simplify that, as I said earlier on, if the numbers are too many, representing them on the Venn diagram will be extremely difficult. So we rather introduce or use their cardinality. When we say cardinality, it is simply the number of elements of the set. So from our previous illustration, P equals count numbers up to 10. So the number of elements in P is 10. M also contains 2, 4, 6, 10, 8, and 10, meaning the number of elements there is 5. That is its cardinality. Where then Q contains 1, 2, 5, and 10. That is factors of 10, and that is 4 elements in that particular set. So instead of listing the members, we can use this cardinality or the number of elements to represent the numbers, the element, instead of listing the elements in the various regions of the Venn diagram. So respectively, the union of Q and M is this, which is equal to 7. The intersection contains 2 and 10, which is equal to 2 elements. Then the number of elements remaining in only Q is 1 and 5, and that's only 2 elements. Then the complement of Q union M is 3, 7, and 9. That is also 3 elements. We have only M to be 4, 6, and 8, and that will give us only 3 elements. So instead of listing or writing each element, we now rather write the number of elements that are supposed to go into each region. So let's see the illustration. So P, instead of us listing all the members in them, you say P will contain 10 elements. Then M will contain 5 elements in all, 4 elements in all for Q. The intersection we saw to be 2 and 10, meaning 2 elements there, and that is the 2 that we've written there. The number of elements remaining in only Q is 1 and 5. That is also 2 elements. Then the number of elements remaining in only M is also 4, 6, and 8. That is 3 elements. So we don't need to list those elements individually, but rather write their total number. Again, the complement of the union of these two sets are 3, 7, and 9. So instead of us writing 3, 7, and 9, we write their total number of 3. When we do this total number we have here, which is the addition of the total number of elements in each of these regions, should give us the total number of elements in the rectangle, which is 10. Let's check that. From here, P being the universal set must contain only 10 elements. M will contain 5 elements in all, including the region that overlap with Q. So if we add all the elements of N and all the elements of Q, we should get the elements of P, that is including the complement. So if we add M and Q plus the complement, it should give us the total number of elements in P. However, from the formula, we can see extra components. So P, which is the universal, and equal to 10, should give us the sum of cardinality of M, cardinality of Q, and cardinality of their complement. So that will give us 5 plus 4 plus 3. So the question is, why do we have -2? The -2 is the intersection of Q and M. Why did we subtract that? If we are adding per region, we are going to get only M plus the intersection plus only Q plus the complement, which will be 4 components or 4 regions, 3 plus 2 plus 2 plus 3. That is exactly 10. However, if we do it M plus all the M plus all the Q, what has happened is that all the M include this region. So it means we are adding 3 and 2 to get a 5. All the Q is also 4. It also means that we are adding this region, which is 2 and 2. What has happened? We have added this particular 2 twice, which shouldn't be the case. It's just like children in the classroom. You go there and you ask them, who eats mango? 5 people raise their hands. Who eats banana? 4 people raise their hands. 3 in that class didn't raise their hands at all. Now, when you add the 5 and the 4 plus the 3 who didn't raise their hands, you'll get 12. Meanwhile, the total number of children in that class is only 10. This simply means that when you ask the number of people who eat mango, the 5 raise their hand. 2 of those who raise their hand that they like mango also raise their hands again that they like the second option. So they raise their hand twice, meaning they have been counted twice. So if we add all these figures, it will now be 5 plus 4 plus 3, making 12. So to have the equation balanced, we have to subtract the intersection once because we counted it twice. Instead of adding it once, we added it twice. Therefore, we have to subtract it once from the answer so that our equation will balance. So that has become the universal set. So replacing the P with the universal set, the M with A, the N with B, we will get universal set will be equal to the number of people, the number of elements in A, plus the number of elements in B, plus the number of elements in the complement of A union B, minus the intersection of A and B. That is because when we add the A and we add a B, the intersection is added twice. Let's go for further illustration and explanation of that. In this diagram, it says that at a breakfast buffet, 93 people chose coffee for their beverage and 47 chose juice. 25 of them like both coffee and juice. So the 25 will come to this region because they like both coffee and juice. The 93 here represents all the people who prefer coffee, and that includes the whole circle overlapping with the juice. So what has happened here? In this case too, it implies that the 95 include the people who like only juice plus those who like both juice and coffee. The 95 include those who like only coffee plus those who like both coffee and juice. So to know those who remain here, we must subtract those who like both coffee and juice from the 95 people sorry, the 93 people. Then to get the number of people who like only Jews, we must subtract this same 25, which is the intersection, from the 47 to get those who will be in only this region. So we have the 25 intersected. So using the formula to know the number, here it says how many people visited the buffet. It means that here we were not given the universal set. So to get the universal set, it's going to be this region plus that region plus the intersection plus their complement. So let's see. To get the universal set, it's going to be the 93 plus the 47. Then we take out the intersection because it says that if each person chose at least one of these beverages, meaning there is no complement. Complement is 0. Therefore, when we add the 93 and the 47, we must subtract their intersection to get the number which visited the buffet. And that will be 150. So this means that, or implies that 115 people visited the buffet. Further illustration again. It says in a college, 200 students are randomly selected. 140 of them like tea, 120 like coffee, 80 like both coffee and tea. So from these two, we can deduce this 200 for universal sets, 140 for all the people who prefer tea, and 120 for all the people who prefer coffee. So to have the people who prefer only tea, we must subtract their intersection of 80, and that will give us 60. To get the number of people who prefer only coffee, we must subtract the intersection again, which is 80, and that will give us 40. So only tea is 40, only coffee is 40, and only tea is 60. Now, if we add this region, the 60, the 80, and the 40, we must get 200. If we don't get 200, it means some people did not choose any of these two beverages. So let's check. 60 plus 40 will give us 100, plus the 80 will give us 180. That is not up to the number of people who were randomly selected. It means that 20 of the people remaining in that selection did not select neither tea nor coffee. So here comes a simple exercise. I hope you have followed this lesson keenly. If you did not understand anything, you can play back the video and get better understanding before you tackle this exercise. Here says, this also shows us in a survey the preferred means of transportation for a group of people. 160 did not go by car nor bicycle. That means they went by different means of transport. Now, out of this, 280 are in this region. What does this region mean? 140 are in this region. What does this region mean? 220 in this region. What does that region also mean? So from the diagram, how many people go by car? Only car. Bicycle? Only bicycle. None of the vehicles mentioned, both bicycle and car, and only one means of transport. Let's go to question 2. It says the universal sets E contain whole numbers less than 20. And A, squares less than 20, B, even numbers less than 20, and C, odd numbers less than 20. And it says draw a diagram for A and C on a for A and C and place the numbers in the correct regions. Meaning A, B, C are all subsets of the universal set E, which means that when you are drawing the Venn diagram, E should be the rectangle. Then you are considering only A and C for question 1, or A as the subset without B. When you come to question B, you are considering B and C as the only subsets to be illustrated on that Venn diagram. Then question C says, shade A intersection B on a Venn diagram. Here too, it means that you are using only A and B as the subsets for that particular diagram, with E as the universal set. Finally, you have to shade a region representing A union B. Similar one was illustrated at the beginning of this video. If you don't understand this, you can go and play that back. Let's go to exercise 3. It says in the diagram to the right, we have E being the universal set again. A contains 50 members, meaning the whole circle of A, 50 members. B contains 25. That's the whole circle of B is 25. And their intersection, which is that region, contains 5. If the universal set is 50, illustrate this on the Venn diagram. Then go ahead and calculate for the union of A and B, and also calculate for A intersection B, meaning you should find the figures for that, which is quite easy because most of these can be found in the instruction above. The last question, it says you should draw a Venn diagram of two sets S and T, where given that S is 15 members, T contains 20 members, whereas their union contains 25, and the universal set E contains 50 members. Draw the Venn diagram to illustrate those figures. Then go ahead and find the S intersection T, and then S union T. S union T. Because this is here is a typing mistake, so note this correction. It's S union T. Thank you, and I wish you good luck. If you don't understand anything, you can play over the video or give me a call on 024-83-64435. Have a blessed day.